He's Warren McCulloch, age 70, an American, a confirmed eccentric, a genuine Renaissance man. Listen to these professional qualifications. Psychologist, psychiatrist, neurophysiologist, doctor, neurosurgeon, philosopher, teacher, poet, engineer, mathematician, and lots more, and an expert in every one of these. His permanent job at the moment is head of the Department of Cybernetics of MIT, Massachusetts Institute of Technology. McCulloch is a genuine character. For example, he usually travels around the world in a cloak and hobnailed boots. He's reputed to live on ice cream and whiskey, has 17 adopted children, never goes to bed before 4 a.m., and can usually confound any expert in any field. He is an advisor to the U.S. government on space matters and is one of the fathers of the modern computer.
Warren McCulloch was born in 1898. To give you an idea of what technology was like during that time, this was only a few months after the first radio was tested, so it's kind of impossible to imagine someone of that time developing things that would lead to kind of what we're talking about today with the possible developments of AGI and things like that. Warren McCulloch's key work was a logical calculus of ideas immanent in nervous activity. This work was done together with Walter Pitts. Now you could say that Walter Pitts could also be considered the father of modern AI, but I use physiognomy as a tiebreaker. So a logical calculus of the ideas immanent in nervous activity, the main kind of output of this paper was something that looks kind of similar to today's Perceptron, but what they were doing was they were taking kind of what they knew about the brain and kind of trying to develop the building blocks of the brain. So you're taking a neuron and then trying to kind of conceive something that could mathematically compute what kind of happens within a neuron, and you come up with the McCulloch-Pitts neuron, very similar to today's Perceptron. The main difference is that there are not kind of updated different thresholds, and then also you don't really have the concept of backpropagation yet, but most of the key items are there. Now there are a side of machine learning that is very close or getting closer to kind of neurobiology. It's a different offshoot of machine learning. But if you look on the far right there, you have something that's very similar to kind of the McCulloch-Pitts activation or neuron. And then you have the second generation ANN that uses some sort of sigmoid activation. So it's kind of developed further. And then if you get something that's very close to the brain, it's a spiking neural network. This kind of adds a time domain and requires successive spikes to be able to cause a neuron to fire, which is very similar to kind of biological systems. Although these systems are kind of not the most kind of powerful that we have now and may not be what leads to AGI. Most things that are kind of most effective are branching off, kind of getting very different than neurobiology. But to give you an idea of kind of the differences, this is a neural network of perceptrons. So you have input images there on the left, and then it outputs the classification on the right. So it's using the image to kind of pick what class it is based on some sort of perceptron network. And then to see what's different about spiking neural networks and why they might be useful is they're very energy efficient, because the neuron has to fire after so many successive kind of activations. So you can see that it's energy efficient. This is kind of a very unmathematical way to see, but you know, you're watching a YouTube video. So here is a kind of the idea of biological systems being very similar in the beginning, and then technology branching off into some sort of abomination. So technology often kind of, when it starts performing really well, stops resembling biology. Otherwise, most of the things we have today would look very different than what they actually are. So if you take some sort of natural mimic is usually where you start, and then you have some sort of kind of abomination offshoot that ends up working really well for technology, maybe not for biological systems, but you've kind of surpassed that and you're kind of going onto some different plane. And that may be what's happening with large language models, is that they may be deviating to something very different than biological systems and may never come back. However, there are some uses for maybe spiking neural networks with particularly interfacing with the brain. It's kind of hard to be seen, but that's a developing field. Going back to Warren McCulloch, he also has a lot of publications about kind of psychology and psychiatry. I think that's kind of the thing that was most interesting to him, but I think he kind of hated the kind of things that were going on within that field. He said that most of it was kind of pseudoscience. It was kind of getting kind of just into strange ideas and kind of degenerate kind of thought processes. And main thing that came out of this was a rebuke of Sigmund Freud. So it's very interesting to see his kind of stance there. He talks a lot of things outside of just science, so I think that's probably one of the most interesting things I read of his. And if you go a little bit further, he has a very interesting paper called Towards Some Circuitry of Ethical Robots. I think this is one of the most interesting papers he had, just going back and reading, because it was published in 1952, and he's talking about kind of things, kind of theorizing about what will happen if AGI is achieved, these sort of things, without kind of saying those exact words. But it's very interesting seeing kind of someone who has that level of foresight in a time when people would have never thought that machines would make it so far and machine learning would develop to what it is today. So he has some quotes in there about talking about kind of these communes of robots living together and challenging each other. It's kind of very interesting. But I think the foresight doesn't stop at Warren McCulloch. There's someone who has a much greater foresight. I guess we can call him the grandfather of artificial intelligence. Leibniz was born in 1646, mid-17th century. He developed the ideas of a logical machine. This is something he actually tried to physically make here. It never ended up working the way he intended. He was still working on it. But I think part of his doctoral thesis, he talks about kind of what we would kind of refer to as like a Turing machine. So he had probably the biggest foresight into what kind of the outputs of kind of modern AI might be. I think reading his stuff is probably the most interesting. Seeing someone who could go from a time so far back and kind of have that level of foresight is insane. I think the most interesting quote he had kind of hints at maybe the dystopian kind of future we might be going towards, where if you have two mathematicians in the future, instead of kind of logically thinking about to themselves what an answer might be to a problem, that they would sit down against each other and say, let's not think about it, let's just compute. So it's kind of very interesting, kind of someone with that level of foresight back then. And don't take my word for it. Wolfram, the guy who helped you cheat in middle school, said this about Leibniz, that he was imagining the whole architecture of how knowledge would be made computational back then. I'm going to have some other videos about this sort of thing. Also, Leibniz actually got a lot of his kind of ideas from older things like Chinese dynasties and some other things as well. So I'll be going into kind of that, and then also I might come back to Walter Pitts as well.